Okay, so last class we kind of ended here, I briefly introduced text visualization again. I think that's a really cool way. And in fact, I think that most of the beginning visualizations we're going to go through are maybe boring, not as cool. But as you start looking at text visualization and other things, networking, they tend to get better, at least in my opinion. I don't know. I guess that's a personal opinion. So talked a little bit about that, and the next part again of this intro chapter is we have to think a little bit about the human side. So there's the technical aspects. We need to have computers. We need to have the data available. Computers visuals that are able to take that data and somehow create pictures, create animations, create interactivity. That especially add interactivity to those. And we already talked a little bit about how this increases mental resources available, but then there's some operations that our visual system can do. And so one example, we can scan for, like, you can probably find your name in a big document if it pops out. So we can scan looking at the document. Filtering here, it depends. Some things are annoying and might actually obscure our vision. Things, that's what ads want to do. You can on a web page, they're trying to get your face. But we can also filter noise, which is a good thing. So if the data has some imperfections, those of you in the data quality field, information quality, data quality, maybe visualizations are able to show those, and our visual system will just ignore the things that don't appear right. So filtering is a two-edged sword. We can filter important information. Our visual system may be able to filter something that's important and not make it really hard for us to find, but also sometimes it works by filtering noise if there's noise in the data. And then we can recognize certain patterns, such as maybe that's the tic-tac-toe's advantage if we do it, tic-tac-toe versus summing game. So there's patterns, lines, columns, X's, diagonals, that's what I mean. And then we can remember images, kind of form a cognitive map. So blindness, I want to talk about that a little bit. And that probably has to deal with attracting attention. So sometimes it's good to have something like what the ads want to do on a website if it's an important change in the data and you want to show it, if you detect that, and make sure people see it. But that's blindness. First of all, change blindness. There's an image here, and then I'll go to the next slide. It's the same image, but one important thing has been changed. And because we just go left and right and the change is sudden, and if the change would have been, if things would flash or you see a red circle surrounding the area where it will happen, or more of an animated thing, you would probably notice it. But can anyone figure out what changed from this to this? It's an important thing for the airplane. The engine is gone. Again, it's easy to miss. That's the whole idea of change blindness. So if, in a way, it's easy to create an animation by just looking at the sales data in January, then you animate immediately, go show sales data. The next second you show sales data in February, sales data in March. But if it's jerky and people might not notice important things that might be important, so it's not always straightforward to just put in a new thing. You want to animate, you want to try and cue and show changes, so that a good visualization system will try and do that. Figure out where, you may need more smart things behind the scenes, or maybe the person dealing with the information just adds something kind of importance, add another column called importance, and have only or 2 or 3 things that are important and they change, and then they kind of see them in a different color in January, and then you can see them changing in February. So there are solutions that can happen kind of at a software level, at a visualization level, even at the data level, if we don't have access and we cannot modify the software. The other one, let me see if I updated the slides. I'll try and see if that works first. To show this, I'll try this video right here. And that, let me see if I can find it. It's a video that's no longer available. And I found it. Okay, let me share my screen. I found it in a different video. I need to update a set of slides, kind of my to-do list. I need to update a set of slides, and homework 2, I need to add the data to it. That I have not done yet. Okay, so let's kind of look at it.
NS test. How many passes does the team in white make?
The problem is you count how many passes.
The answer is 13. But did you see the moonwalking bear?
Okay, so that's the one name for that. I guess there's probably more. It's inattentional blindness. You're not looking for it, you might not see it.
Interventional?
Inattentional. So no attention, you don't pay attention to it. So that was the moonwalking bear. Let me go back to the files. So it's this one, inattentional, and then change blindness is the one with the engine. As far as is visualization working, oh, that's the name I was looking for. Remember this? This visualization that was done, kind of, they were trying to do automatic visualization on it. I don't know if it's Tableau or Spotfire. That's the grandchild of that thing. But there's obviously tools, people spend money on them. Tableau is pretty expensive if you want to buy it. And there's something called Visual Analytics Center. There's a Pacific National Visual Lab. There's research, maybe not for pure visualization anymore, but various combination to other things, different types of data. So there's certainly activity. Is it good for everything? No. Like I just trying to show what partial derivatives are, or integration, or there are some mathematical constructs that are pretty powerful. Once you understand them, you can kind of solve a lot of things that would be harder to solve with the visualization alone. It's hard to prove a negative. So maybe there's some good visualizations for that. But for a lot of things, there are other analytics tools. Like I said, very, very powerful math or advanced math, calculus, and so forth. Then we have statistics that can do a lot of machine learning, all of that. They're coming in. So different things work differently. So that's, I want you to be critical of everything. So it's, yes, it's a visualization class, but visualization not the end for every problem. And in reality, if you want to see if visualization works, because of its softness, the best way to do that is to run an usability study. So if you want to compare two visualizations, you need to run them. Go in front of the user, put them in front of it, see which one helps them solve the problem better. It's generally into what matters is, you know, what the Okay, I believe something happened to maybe Collaborate or Blackboard, because my internet seems to be working and I see a lot of people coming in and out. 1, 2, testing.